So, if you've ever looked at some complex software and just wondered, how in the world is that even built? Well, the answer almost always starts with one of the most powerful ideas in programming: classes and objects. Today, we're going to break down exactly what they are and, more importantly, why they're such a game changer. Okay, let's put you in the driver's seat. Imagine you're building a system for a school, and you've got to manage students. We're not talking one or two, we're talking hundreds, maybe thousands of them. Every single one has a name, an ID, a bunch of courses. How do you possibly handle all of that data without your code turning into an absolute train wreck?
Well, the answer to that potential chaos is this really elegant tool for getting organized. It's called a class. And honestly, the best way to wrap your head around it is to think of it as a blueprint. A blueprint for your code.
So, what is a class, really? Well, here's the key: it's not the thing itself, it's the plan for the thing. You know how an architect's blueprint describes a house before a single brick is laid? That's exactly what a class does. It describes an object before it's ever created. And it lays out two crucial things: the data it's going to hold, we call that its state, and the actions it can perform. That's its behavior. Here's another great analogy for you. Think of a class like a blank form you'd have to fill out. Like a registration form. The empty form itself isn't a person, right? But it tells you exactly what information you need to collect to create a record of a person: name, address, phone number, and so on. It just defines the structure. All right, so we've got this blueprint idea down, but what's actually written on it? What are the instructions? Let's zoom in and take a look inside. So, what actually goes inside this blueprint? Turns out, it really just breaks down into a few key parts that all work together. First up, you've got fields. These are pretty much just variables that live inside your class. They represent the data, the characteristics. You can think of them as the nouns of your object. So for a student blueprint, the fields would be things like name, student ID, maybe GPA. This is the state we were talking about. Now, there are a couple of things to know about fields. Most of the time, you're going to be using what we call instance fields. All that means is that every single student object you make gets its own personal copy of the name and ID. So my student object has my name and your student object has your name. They're separate. But, and this is crucial, look at that last point: making them private. This is like putting a protective wall around the data. It stops other parts of your code from just reaching in and accidentally changing a student's name or setting their GPA to something crazy like -50. It's a huge safety feature. Okay, next up, methods. And this is simple. If fields are the nouns, then methods are the verbs. They define the actions, the behaviors. They're all about what your object can actually do. So a method is really just a named chunk of code that does something, and it usually works on that object's own data. The payoff here is massive. Instead of having messy code all over the place, you can just call student.enroll or student.calculate GPA. It just makes your code so much cleaner and easier to read. You know exactly what's happening. And finally, there's one more special type of method you got to know about. It's called a constructor. I like to think of it as the assembly line manager. The moment you say, hey, I need a new student, the constructor is the one that springs into action. It grabs the blueprint, assembles a brand new object, and makes sure all its starting data is set up and ready to go. And this right here, this is the magic moment. In your actual code, you literally type the word new. That one little keyword kicks off this whole process. The constructor automatically runs, it sets up all the starting info, and bam, just like that, you have a brand new, fully formed object ready for you to use. Which, brings us perfectly to the other side of this coin. We've spent a lot of time on the blueprint, the class. So now, let's talk about the real thing that gets built, the object. So what is an object? It's just a real, live thing in your program that was made from a class blueprint. So if your student class is the blueprint, then the actual student John Doe with the ID 123 is an object. It's a real, concrete instance of that class, taking up space in your computer's memory. And this comparison here just nails the difference. The class, that's the abstract idea, the blank form. The object, that's the form filled out with real, actual data. A class isn't alive, it's just a plan on paper. But an object is alive, and you can actually use it in your program. And that's why you can have one single student class, but create thousands of completely unique student objects from it.
So how do you actually interact with one of these live objects? It's super simple. You use the dot. Yep, just a period. You take your object, like student, add a dot, and then you tell it what to do by calling one of its methods, like getName.
Okay, so that's the what and the how of classes and objects. But the biggest question, the most important one, is why? Why do we bother with all this? Why do pretty much all modern programmers build software this way? Let's talk about the payoff, because there are some big ones.
Benefit number one is just organization. It's huge. Instead of having student names over here and the functions that manage them way over there, a class just bundles it all together. The data and the actions that use that data all live together in one neat, tidy package. No more hunting around for stuff.
Second, you get reusability. And this one is a massive time saver. You write that student class blueprint just one time. And after that, you can stamp out 10, 100, even 10,000 unique student objects from that same plan. You do the hard design work once, and then you get to reuse it over and over and over again.
Number 3 is safety. Hey, remember that private thing we talked about earlier with the fields? Well, this is the payoff. By hiding the data inside the object, you're essentially creating a protective shell around it. You force everything to interact through your safe, controlled methods. This idea is so important it has a name. It's called encapsulation. And it's what stops some random part of your program from accidentally setting a GPA to -100 or messing up a student's name. And finally, there's clarity. At the end of the day, your code just starts making more sense. It stops looking like a jumbled mess of instructions and starts to actually model the real world. I mean, when you read code that says timer.start or car.accelerate, you instantly get what's going on. It's just plain intuitive. So look, if you take away just one single thing from all this, let it be this right here. A class is the form. An object is the form filled out. It's the blueprint versus the actual physical house. Get that? And you've got the core idea. Honestly, this one concept is the absolute key. It's the foundation for building pretty much any complex, organized, and powerful application you can think of. So, now you have the blueprint. What are you going to build?